Hi, my name is Jungkyu Park. I run Nanoscale Heat Transfer Lab. I'm Associate Professor of Mechanical Engineering. We study heat transfer in nanomaterials, mostly in three-dimensional nanomaterials. Then why is it important? Because we are making electronics smaller and smaller, and then problem is if you make circuits smaller, you increase the resistance, and that will increase the amount of heat generated, and that's a big problem. The breakthrough came out when people developed these new materials like graphene or carbon nanotubes. So they are low-dimensional nanomaterials. They have very high thermal conductivities, and they have very high mechanical strength. For example, the graphenes is kind of one layer of graphite. So it has like 100 times higher thermal conductivity than steel. So it's exciting material, and they are very strong at the same time. So far of the 3D carbon nanomaterials that are available at the market, for research is only 3 types: carbon nanotube sponge, and graphene foam, and carbon nanotube networks. My research is then what would happen if we deform this material? Then what would happen to the thermal properties, heat dissipation properties when they are deformed? Because that's important in flexible electronics and wearable devices. So I used atomistic simulations to predict that. Most of the conventional materials, if you deform materials, they actually have degraded thermal conductivities. This kind of makes sense. You deform something, you decrease the thermal conductivity, heat dissipation property there. But this material, if you deform, interestingly, they actually show higher thermal conductivity. So that was my prediction. That was one of my discoveries. You can have some material that have high thermal conductivity in multi-directions. And also it's kind of porous. You have a lot of empty spaces. So it's lightweight and they are strong. So you will have a very strong, lightweight material and at the same time have very high thermal conductivities